Yeah, good morning. Good morning, guys. Let's give everyone another minute or two. Okay, good morning. Good morning. If someone could type in the chat if they could hear me correctly, that would be great. Anyone can hear me? Yes, awesome. Thank you, Patience. Okay, so thank you guys. So this is going to be the virtual group. And so on Fridays, we'll meet and I'll send out the link like I did ahead of time, and we'll just go through some material. If at any point you have a question, you can either put it in the chat or you can unmute yourself and ask. So I'm also going to record these so that in the future people can watch them back in case they have other questions. Okay, so I'm going to share my screen with you guys. Let's make sure I can still see the chat feature. Okay, so sorry, I'm just getting myself set up here. Okay, so this is where you saw that announcement. I'm going to go through the agenda. So what we're going to cover in this class, I'll have you guys do a short quiz just as my way of double checking that you're here. And then I will I'll go through some slides that I prepared based on questions that you guys had about the first two chapters. And then we'll do some activities related to those first chapters. And that's kind of going to be the format for these classes is we'll do attendance. I'll go through some questions that I had previously gotten, and then I will we'll do some activities. Okay, hold on one second. I've got, I think, someone waiting in the waiting room. Let me let them in. Okay. Good morning. Good morning, those of you joining us. Good morning. Okay. So we're going to start with the Class 1 attendance quiz. So if everyone could log on to their Canvas site on their own device, and I want you to open up this quiz. It says Class 1 attendance quiz. And what I want you guys to do is the question I want you to ask is I want you to tell me your favorite color. So if you could write, that's the question I'm asking. What is your favorite color? Not that hard. They might get harder as the weeks go on, but week one, let's just start off nice and simple. If you could take a minute, find this quiz, and then tell me your favorite color. And while you do that, I'm going to get set up here. Okay, everyone done that quiz? I'm going to assume the answer is yes. Okay. Can people see my screen okay? If someone could tell me in the chat if you can see the screen. Okay. Yes, thank you, Tanya. Okay, thank you guys. You know, it's hard to tell what's happening in a Zoom class. Okay, so we're going to go through some questions and clarifications that I had gotten from materials from chapters 1 and chapters 2. The first one is patterns of chemical reactions. So for chemical reactions, I don't need you guys to learn a bunch of chemistry. Okay, I don't need you to learn a bunch of chemistry. I know that this is not a chemistry class. I know that a lot of people are intimidated by chemistry, and so we're going to keep it pretty basic, especially when it comes to chemistry. I just want you to understand that our bodies sometimes need to make things, especially when we talk about macromolecules. When we talk about macromolecules, they're made from smaller monomers, from smaller pieces that are put together in a specific way. And so for that, I really want you to understand that our body does synthesis reactions. So what a synthesis reaction is when you're going to take those smaller pieces and you're going to make something bigger. So for example, our body can take a bunch of amino acids and they'll put them in a chain and they'll get a protein or a peptide. Now, for our macromolecules, there are 4 different types of macromolecules. We've got carbohydrates, proteins, lipids, and nucleic acids. For these, I don't need you to draw me a chemical structure for them. So everyone, take a deep breath. We're not going to be drawing these chemical structures. I do, however, want you to be able to recognize the chemical structure and be able to say, oh, that is a blank. That is a monosaccharide. That's a disaccharide. That's a polysaccharide. So the way that we're going to remember carbohydrates is we're going to think about Fruit Loops. Fruit Loops are a very sugary cereal. They're not very good for you. They're pretty delicious, but they're full of sugar and they are shaped kind of like a loop. And so when we think about Fruit Loops, we're going to think carbohydrates. And so a monosaccharide, that is 1 Fruit Loop. A disaccharide is 2 Fruit Loops. And then a polysaccharide is a chain of Fruit Loops. Lots and lots of sugars, okay? Now, let's talk about lipids. Lipids are different from our other macromolecules because they don't have the same monomer forming a chain thing, right? Sugars, we've got the monosaccharides all linked together to form a polysaccharide. For proteins, we've got the amino acids all linked together to form a protein. Nucleic acids have nucleotides all linked together. But for lipids, it's not the same sort of thing. So that is the way that lipids are different from other macromolecules. They are still important, right? Lipids have some key roles, but their structures are a little bit different. So the way we're going to think about triglycerides as one of our types of lipids is we're going to think tri meaning 3. And so a triglyceride has a glycerol, and then it's got 3 chains, and they're going to look like just little line chains because they're hydrocarbons, and there are 3 of them, okay? So for our saturated fats, we're thinking solid at room temperature. We're thinking about butter. We're thinking about lard. We're thinking about, I'm actually not quite sure what lard is. I just know it's a very solid fat. But either way, we're thinking about those things for saturated fats. And these have those 3 chains, 1, 2, 3, and they have no double bonds. And so they're perfectly straight. And because they're perfectly straight, they're able to get really, really close together. And because they're really, really close together, they're solid. Now, our unsaturated fats, on the other hand, they have that double bond. They have that double bond. And you can see right away what that double bond does. It creates this little kink in our fat, in our fatty acid. And you can't bring those 3 fatty acid tails as close together anymore because of that double bond. And because of that, because they're more spread out, they're liquid. So we're thinking things like olive oil, canola oil, avocado oil, all sorts of weird oils that you can buy now. If they're liquid, we're thinking unsaturated, okay? Now again, if you have questions at any time, please put them in the chat or unmute yourself and stop me. I sometimes get on a roll, but I'm gonna keep going. Okay, phospholipids. We're gonna come back to phospholipids when we talk about our cells because phospholipids form membranes. Phospholipids form membranes. They're super important for that. And they've got a polar head group, right? A polar head group, it's got a charge on it. And they're similar to triglycerides. You see that glycerol backbone, but they only have 2 fatty acid tails. So unlike the triglycerides, tri meaning 3, these phospholipids only have 2 fatty acid tails, and we'll come back to them. The last structure I want you to remember for our lipids are steroids. Now, most of the time when people think steroids, they think weightlifters, right? They think people shooting up with needles and stuff, right? Getting muscles. I want you to remember steroids based on that idea of weightlifting. So the way I remember it is I think of these rings as the weight plates. I don't know if there's a more technical term. I'm not one who frequents a gym, but I have been told that those weight plates that you place on the bar, right, and then you're gonna lift it or lift it this way, they're circular, right? So we're placing 4 weight plates onto our bar, 2 on each side, so it's not all lopsided, and then we're getting a steroid from that. So we're going to think of a steroid as a weight plate situation. Okay. So let's keep going. We got amino acids next. Amino acids form the basis of our proteins. The way we recognize an amino acid is they've got an amine group, which just means like a nitrogen, and then they've got an acid group. And what's shown in green is their R group, which changes. So each amino acid has their own specific R group. And for proteins, we've got multiple layers of structure. We've got our primary structure, which is the chain of amino acids. Then we've got our secondary structure, where we've got helices and sheets. We've got a tertiary structure and a quaternary structure. Okay. Finally, we got nucleic acids. And I want you to remember DNA. It's a deoxyribose sugar, right, with a phosphate group and a base. Phosphate, our sugar, remember the Fruit Loop? See the Fruit Loop there? And then we've got a base. And there are 4 different types of bases for DNA: adenine, thymine, guanosine, cytosine, A, T, G, C. And together, they form a double helix, so a twisted ladder structure. Okay, so that concludes the questions that I had gotten based on chapters 1 and 2. If you guys have other questions about chapters 1 and 2, please put them in the chat or unmute yourself. In the meantime, what I want you guys to do is I want you on the agenda to open up this worksheet. I want you to open up this worksheet, and I want you to read through part 1, and then we're going to work on part 2 right now. So read through part 1 and then jump to part 2, where we're going to be using some directional words to fill in this blank. And I'm going to try to put you guys into breakout groups. And what I want you to do is I want you in your group to talk about what goes in each of these blanks. So which of these directional words are you putting in each of these blanks? And we're going to see if I can get that to work. So everyone right now, go to the agenda, download that. I'm going to stop sharing my screen, and instead I'm going to put you guys into breakout rooms. Here we go. Let's see if I can figure this out. Breakout rooms, assign 10 participants to 3 rooms. Okay, here we go. Okay, so please go join and move to those breakout rooms for your worksheet. Okay, welcome back. Let's give everyone another minute to leave their little breakout room situation. Okay, coming back. Okay, welcome back, welcome back. Okay, so let me share my screen again here. Okay, so let's talk about, let me make sure I pull up the chat. Okay, let's talk about the answers here. So for the first part of this worksheet, we talk about anatomical position. And anatomical position is super important because it is the standard reference point for everything. And anytime you talk about directions, we're talking about the body when it is in anatomical position, okay? Not when it is in any other position. And so before you get to the directions, you have to understand anatomical position. In anatomical position, a person is standing, their feet are parallel, and their palms are facing forward. That's usually the most awkward part about anatomical position, and the part that people kind of trip up sometimes is the hands are facing forward, so the thumbs are facing out. With that in mind, let's get to directional terms. Now, directional terms, sometimes people have issues with them because they get tripped up and they get caught up in all of these words. And so what I want you to do if you find yourself having issues thinking in anatomical terms is to first think about what you would say in English to describe the direction, and then do like a translation. So what is the anatomical term for that? So let's start by talking about our thumb to our ring finger. The thumb is more towards the outside of our body than our ring finger when we're in anatomical position. Our thumbs are facing out, okay? And so the word that means more towards the outside is lateral. So the thumb is lateral to the ring finger. Then we have the ear. And again, the ear is more towards the outside than the eyes are. So we again would say lateral. Our abdomen is beneath our thorax, which is our chest cavity. And so we would say our abdomen is inferior. The skin is above our skeletal muscles or more towards the surface. So we would say superficial. Now for our limbs, this is another spot that people often get tripped up on. And for limbs, we don't use superior or inferior, meaning up or down. Instead, we use proximal and distal. Proximal meaning closer to the spot where the limb attaches to our body, and distal meaning further away. So we would say that our shoulder is more proximal to the elbow. It's closer to where the body is than the elbow. And the reason we don't use superior or inferior is because say you put your arms up in the air, right? Now your hands are up. If your arms are down, your hands are down. Those inferior, superior words are going to change depending on how you're holding your limbs, but with proximal and distal, we don't have that issue, right? So we would say the shoulder is proximal to the elbow, but the hands are distal to the elbow. Okay. So what I want you guys to do, I'm assuming in your breakout rooms you actually worked on this, right? I'm assuming that that's what happened. So what I want you guys to do is on Canvas, I want you to submit what you have. Now it doesn't have to be done. But I want you to submit it. So where it says class 1 language activity, I want you to just submit whatever you have. It says, please submit the completed version. Don't worry about that. Just submit whatever you have right now worked on in your group as a way of showing me that you did something in that group, okay? We're now gonna move on to the second activity here. And again, for the second activity, you're going to just submit whatever you have. So this is going to be our class 1 case study. So if everyone could open up class 1 case study. It's case study 1, macromolecules. And for this one, we're only going to work on parts 1 and 2. This one, we're only going to work on parts 1 and 2. Okay. And for the first part, it's kind of long. So what I want you to do, we're not going to do breakout rooms for this one because it's just mainly a lot of reading, and then it's 2 questions. So what I want you guys to do is to read through to yourself part 1, and then read through part 2, and then on a separate Word document, answer question 1. And for question 2, we're not going to draw anything. So I want you just to describe. So read through part 1, read through part 2, answer question 1 and 2 on a separate Word document. And then at 9:40, we're going to talk about it. At 9:40, we're going to talk about some bonds and some electronic configurations. Okay. So you guys have 10 minutes to read those 2 pages and then talk about, and then think about those 2 questions and type up responses. Okay. And then be prepared for talking about it at 9:40. Okay. So take 10 minutes, read to yourself.
Where are we turning in the worksheet?
Good question. Okay. So if you go to the home page, and you scroll down to class 1 activities, the class 1 language activity is the one we just did. So this is the anatomical language. We just did that. All you did is part 2, so that's fine. So what I want you to do is submit that here. And then now what we're working on back at the home page is right here, the case study. And all you're going to do is submit those first 2 questions. So we're reading part 1, we're reading part 2, and then we're going to turn in typed answers to question 1 and question 2, ignoring the draw part. Any other questions you guys have? Okay. Work on that till 9:40. I'm going to get some more water, but I'll be right back. 9:40. I'm going to ask that when you're done with your 2 questions, if you could write done in the chat, just so I know when people are finishing. Done. Okay, try to finish up in the next 2 minutes. And then I'll talk about it for a few minutes. We'll go through again just part 2. Okay, so let's talk about those first 2 questions. And the first one we want to talk about are bonds. And so for bonds all about electrons. Okay, bonds are going to be all about the electrons. And when we have, let me see if I can do this right. This is going to be interesting. Okay, so if we have the nucleus here of an atom, inside the nucleus are going to be our protons and our neutrons. And around the outside, those are going to be our electrons, right? We've got the electrons floating around the outside here. And when 2 atoms get close to each other, the first things that interact are the electrons. Okay, and so atoms will bond to fill their outer shell of electrons. That's the rule. That's the rule you need to keep in mind. Atoms are going to bond with other atoms until they have a full outer shell. And so let's talk first about ionic bonds. And so ionic bonds, oh, if I could spell, man. Ionic bonds, this is when we're going to transfer our electrons. So in an ionic bond, we're going to have 1 atom, and we're going to have another atom, and one is going to say, hey, I got an extra electron, and it's going to pass that extra electron and it's going to give it to this other atom. Okay, it's going to fully transfer it. So if it's giving away that electron, it then becomes positively charged, and the atom that gets the extra electron becomes negatively charged. Does that make sense to everybody? I hope so. Again, if you have any questions, please stop me by unmuting yourself or putting it in the chat. Okay, so an ionic bond, we're going to fully transfer an electron. In a covalent bond, on the other hand, this is where we're going to share, oh man, typing, share electrons. So we have, instead of one atom fully passing it to the other, we're going to have one atom and a second atom. And what they're going to do is they're going to share their electrons together. They're going to share their electrons. Okay, so they're going to share those electrons together. And we have two different types of covalent bonds. In our nonpolar bonds, they're shared equally. But in our polar bonds, they're shared unequally. What this does is it creates a partial charge. So our polar bonds create partial charge. And what that means is that for our polar bonds, we're going to have, again, we have two atoms here. And rather than sharing them equally, one is going to share them a little bit more. So there's going to be a denser electron cloud around one, and there's going to be a thinner electron cloud around the other one. So they're shared unequally. And what this does is it gives a negative charge to the side that has that dense electron cloud and a positive charge to the side that doesn't have as much of the electrons. And the classic example of this is going to be water, right? The classic example of a polar molecule is water. We're going to think H2O when we think of polar molecules. And that's because the oxygen is greedy and it's going to steal most of those electrons, okay? It's going to steal most of those electrons, giving it a partial negative charge, and giving the hydrogens a partial positive charge. And this brings us to our last kind of bonding, which is hydrogen bonding. And this is where we have polar molecules interacting. And usually it's a hydrogen to an oxygen. It can also be a hydrogen to a nitrogen. And it's that partial positive charge that's left on the hydrogen interacting with the partial negative charge on the oxygen or the nitrogen. So that's that first question, right? Tell me about bonds. Again, we're going to think bonds are like electrons, all about the electrons. What do the electrons want? They want a full outer shell. How are they going to get it? They're going to transfer or share. Now, the last question asks you about sodium chloride, and that's that example here of the ionic bond. For this, the sodium is the thing that becomes positive because it transfers that electron to chloride, right? Chloride becomes negative because it has an extra electron. Okay, I'm going to save this beautiful whiteboard I made. I will post this as well as the video once it becomes available. I wanted to do one last thing and show you guys on Canvas. Oh, one last thing, desktop, share it. Okay, so some things that you guys need to be working on Canvas before next Friday. Okay, some things you need to be working on. If you haven't done the syllabus quiz, please do the syllabus quiz. Okay, now the guided reading questions are all due at the end of the module, and basically what they are is they're questions that go through your textbook, and as you're reading, they give you ways of guiding your reading. They become like a study guide that you're making for yourself, right? That's important. And so theoretically, before this class, you read through chapters 1 and 2 and did those guided reading questions. Before the next class, I would like it if you got up to chapter 3. Now, again, they're not due until the end of the module, but please don't put these off to the last minute. So before the class 3, if you could try to get up, before the next class, if you could try to get up to the guided reading question 3. I made some videos about that chapter as well. And then there's a discussion post that's due on the 19th that you should be aware of. And what we'll do next time is we'll have an attendance quiz. This is a spot right here, questions and clarifications for guided reading question 3. While you're reading through chapter 3, if there are things that don't make sense, please put them in that in that questions and clarifications assignment, and that kind of guides the little PowerPoint that I give at the beginning, just to go over some things, okay? And we'll work on this thing about the cellular organelles. So I'm going to stop sharing here. If you guys have any questions, please let me know. Otherwise, you are all set until next week. And I'll stick around for a few minutes in case you have questions.
Can you repeat the second question on the case study?
Yeah, so that was about sodium and chloride. And so sodium is going to be giving its electron to chloride, making the sodium positive and the chloride negative. Does that make sense, Jesse?
Yeah, thank you.
You're welcome. Where do we add the 2 questions for the case study, the one that we just did? Oh, so on Canvas, it says class 1 activity case study 1. That's where you submit that, Tanya. And then do we need to submit the worksheet for the macromolecules today? So just submit what you did for the macromolecules. So you just did those 2 questions for part 2. You just submit that where it says class 1 activity case study, just to show me that you were following along. I won't grade those for whether they're right, whether you did all of it. It just, again, it's showing me that you're actively engaged. Any other questions people have? Okay, otherwise you guys are good to go. It's going to kick me out here in like a minute or 2. Any last questions? Going once. Going twice. Esperanza, you good?
Yeah, I'm good. Thank you so much.
You're welcome. I'll see you next week.
Bye. Have a good day.
You too.